Hi everyone. Today I'm going to be talking about probability of independent and dependent events. So here we have a spinner, and a lot of the times they'll ask you what's the probability of like two things happening, like thing 1 happening and then thing 2 happening. So in our case we have the probability of landing on a 2 and then landing on a 1. So the way I like to think about this is okay, what I like to express my probability as a fraction. So number of what I want over the number of total possible outcomes. So what do I mean by that? So for the first part where we're trying to land on a 2, the probability of that happening, well, looking on the spinner, how many 2s do we have? We have 1. Out of how many options in total? 3. Okay. So for my first part, the probability of landing on a 2 is 1 over 3. Okay. And then we're going to think about the probability of landing on a 1. How many 1s do we have on the spinner? 1. Out of how many options? 3. And what you're going to do is you're going to multiply the two fractions. Okay. Whenever you multiply fractions, you multiply the numerator with the numerator. So in this case, 1 times 1 is just 1 over 3 times 3 is just 9. So our probability of landing on a 2 and then landing on a 1 is 1/9. Here's another problem. So here we're picking a card at random, and then without putting the first card back, you pick a second card at random. What is the probability of picking a 4 and then picking a 5? So let's think about the first part. So we're trying to pick a 4. So how many 4s do we have here? Well, we have 1 out of the 4 options, right? And then we're trying to pick a 5. But we gotta be careful here. We are not putting the first card back, which means after we pick a 4, we're just gonna cross this out. Okay, and now we're gonna try to pick a 5. How many 5s do we have? We have 1 out of the 3 options. We're gonna multiply the two fractions. 1 times 1 is 1, 4 times 3 is 12. So the probability of picking a 4 and then picking a 5 is 1/12. Here's another problem. Here we are rolling a 6-sided die 2 times. And we're being asked what is the probability of rolling a 4 and then rolling a 1. Well, let's think about a 6-sided die, right? How many 4s are there on a 6-sided die? Well, there's 1 4 out of the 6 sides. And then for rolling a 1, right? Similarly, there's only 1 1 on a 6-sided die out of the 6 faces. We're going to multiply these two fractions and we're going to get 1 times 1 is 1 and 6 times 6 is 36. Okay. Here's another problem. Here we're flipping a coin twice and we're being asked the probability of getting heads and then getting tails. Well, let's think about a coin, right? How many heads are there on a coin? There's 1 out of the 2 faces, right? And then similarly for tails, we have 1 tails over the 2 faces, and we're going to multiply the 2 together. 1 times 1 on the top is 1, and then 2 times 2 at the bottom is 4. 1 over 4 as a decimal, if you put that in the calculator, is 0.25. And if you multiply that by 100, you'll get 25%. Okay? And I have 25% here because the question asks us to write our answer as a percentage. Okay, so it's 25%. Here's another problem. Here, we're picking a card at random, And without putting the first card back, you pick a second card at random. And we're being asked, what is the probability of picking a 7 and then picking a number greater than 6? Well, let's see. For the first part, we're trying to pick a 7. How many 7s are there? There's 1 out of the 3 options. Okay? But keep in mind that we're not putting the first card back, so we're going to cross that out. Okay? And then we're trying to pick a number greater than 6. Well, after I take the 7, there are no more numbers greater than 6. So there's 0 choices out of the 2 options. We're going to multiply the 2. 1 times 0 is 0. 3 times 2 is 6. And 0 divided by 6 is 0. In other words, this is impossible. Okay? Probability is always a number between 0 and 1. Okay? 0 meaning impossible, 1 meaning it's guaranteed to happen. Okay? So it's 0. Here's another problem. This time we're picking a card at random. Without putting the first card back, you pick a second card at random. And we're being asked, what is the probability of picking a prime number and then picking a prime number? Well, let's talk about what a prime number is. So a prime number means you can only get that number by multiplying by itself and 1. So for example, 2. You can only get that by multiplying 1 times 2. Similarly with 3, you can only get 3 by multiplying 1 and 3. So here's a list of all the prime numbers up to 20. 2, 3, 5, 7, 11, 13, 17, and 19. And you'll notice that most of these numbers are odd. Okay? And fun fact, 2 is the only even prime number. Well, why is that? Well, let's think about it, right? Like, for example, 4 is an even number. I can also get that by doing 2 times 2. Same thing with 14, for example. Because of 2, right? All the even numbers are divisible by 2. I can get 14 by doing 2 times 7. Okay? All right, so let's think about this. Probability of picking a prime number. Well, it looks like I have 1, 2 prime numbers here. So I have 2 prime numbers out of 6 choices. Okay? But keep in mind, we're not putting the first card back. So we took a card, and we're not putting it back. So in this case, we could have picked 5 or 7. I'm just gonna put you can cross out either one. I'm just gonna cross out 5. Okay, and then we're picking a prime number again. Well, this time we only have one prime number out of 5 choices, and now we're gonna multiply the two fractions. 2 times 1 is 2, and then 6 times 5 is 30. Okay, if you simplify that, you can divide the top and bottom by 2 and get 1 over 15. If you put 1 divided by 15 on your calculator, you should get like 0.0666 repeating. Okay, if you multiply that by 100, you'll get like 6.666 as your percentage. Okay, so for IXL problems, they usually want you to convert the decimal to the percentage first. Okay, but keep in mind, they want you to write your answer rounded to the nearest tenth. So this is our tenths place. We're going to look to our right door neighbor. Is it 5 or higher? Yes. So we're going to round up. Okay, so we're going to get 6.7% as our final answer.